Alright, let's get started then. Where was I? Let's see the hardware. Yeah. Okay. So. Right. Okay. So I was here, and I was making difference. Right. I defined. Radix sort. No. I don't need this. Now do I need this? Okay. Radix map. Yeah. Test operations. Min pose. Min position. Radix map underscore find min position. Right. Yeah, there is my function xmap find min position. So I had successfully found min position. Then okay, so it needs a key, right? So I can use static void map radix map sort. Then I can also use 32t key to add, right? This is the key to add. Then radix map sort is the radix map add. Okay, so radix map sort. So we just pass in the key, right? Okay, radix map find. We have radix map sort key to add. Then I go. Okay, maybe int min position equals what is this? Radix map underscore find min. Radix map underscore find min, and we pass in the map as well as the key to add. Okay, so we pass in the map as well as key to add. Then we okay. Yeah, okay. So with radix map content low is greater than high, map end -1. Okay, yeah. So it doesn't really matter because there will be no element there. As low is less than equal to high. So when the okay, but if it adds something, right, because this function won't be called unless you add something, right? Okay, so this function won't be called. So this note also this function won't be called unless you add something. Therefore we don't need to worry about checking the size of the checking if the map is empty. as the first time this function gets called is when an element gets added. So by default the map would not be empty. Right, key to add, then key to add, and then we pass this min position this is the minimum position, find, and let's temporary comment. Maybe I should like this, right? We go find min, right? Okay, so we add, and this should be sorted. Function to check order, right? Okay, so let's see. Map add, test search, check order, test search, test operations, temporary comment. Okay, test find min. So I also add here a temporary comment, then right, okay, so I want to manually check. Okay, let's say take a temporary utility function void display map. I've taken the radix map, then we go then what do I want to do is, what do I want to do? Okay, data dot keys. I just want to take a look at the keys, right? The element, we have contents, and then we have an and. Okay, so int I equals 0, I less than map end, and I plus plus, we go maybe okay, we'll stick with a regular printf. Map contents RME element, map contents, then we provide feature dot data dot key, and it will give me an error, so I'll put an unsigned, right, at u, right? Yeah, okay, so, and in the end we print a new line. Okay, so displaying the map, let me go radix map underscore add like this is the function, right? Underscore map key and value. Okay, so we go radix underscore map. We pass in the map key is 1 and value is 2. I want to adding elements to the map, displaying the map, and then I go display map. Okay, then I'll go temporary comment. Okay. So let's go and make. Radix map sort map.c n function radix map.c 208. Yeah, that's what I didn't want to do. Radix map. Okay, I will just provide it some value. Radix map. I want to sort. Okay, let's forget about sorting, right? Okay. Temporary comment. Let's try again. Clean W. Clear. Let's make it again. Okay, test run. Right, but this is one. It showed me. Okay, let me go to right. Then radix map underscore add map 1. So it should could not find source dot. Oh, okay, right. So I should remove it from this make file. Yeah. Go make 2 and 1, but that is wrong, right? That is wrong, since it should be 1 and 2. So it should be 1 and 2. Shows 2 and 1, so it is not sorting right. So it is not sorting it right. Okay, oh shit. Okay, right. So of course it won't be sorting it since I have deleted this. Okay, let's try it again. Make clean W and make. Okay, so now it seems to be stuck, right? Okay. Yeah. Okay, so let's let's go in this function. Let's printf men pause what does it return? 132. Okay, so we'll make it a unsigned int 32, and I want to make clean w and make it again. This is not looking right. Okay. Okay, let me just try this. Right. Let me just try this. Okay, still. Okay, so even in adding, right, it has a hard time adding. It's not key to add. Declare a const. Not wrong. Okay, let me print f low, high. Low, high. Okay, low and high are 0. Right. And high are 0. Takes that. Maybe I should run it through GDP. Test. Yeah. Run it through GDP. GDP test, yeah, run. Okay, so it ends here. Switching, yeah, okay. So we check is contents are okay. Okay, contents are okay. Then I think it seemed to be getting stuck in this loop. This key, okay, I think else, right, it is okay. This means that the keys are equal. That means the keys are equal, possibly indicating, okay, key is less than, no, it is not less than. Is it higher? No, it is not higher. So here the position remains high, right? Okay, so it is getting stuck in an infinite loop. Okay, this means that the keys are equal. If keys are equal, okay, right, but if keys are equal, right, having similar keys should result, right, we can have only unique keys, and if I have a indicating okay, this means that keys are equal. Okay, equal, and not including this statement seems to equal, not including this condition. Okay, so keys are equal, so we simply return middle, right? Middle. Okay, this is okay, this is also okay. Let me just let me just try it once, right? This is clear, make clean W and we make it, and position, min position is 2. Okay, so I must have put here, min position is here, then we go we add map key1, and it should automatically 1 and 2. Yes. Okay, so it sorts them continuously. Okay, now say me see 3, right, map, then we go, then I want to add a key with 2. So what would that look like? See 1 3 and 1 2 3. Okay, so this feature works. Okay, this means that the keys are equal, not including this condition seems to put start an infinite loop. We simply return the middle the index indicating the middle itself. Okay. This can occur in two cases. One, there is only a single element in the map, and two, you are adding you are adding an element with a key that already exists in the map, right? So this is the condition. Find map, we calculate isolate key to add or delete. That really depends on key to add or delete. Key to add or delete. We can have tokens. It doesn't really matter. Okay, first we compute the position of the element just preceding element with a key just smaller than the element we want to add or delete, right? Okay, so return null, right? Okay. So this works, then delete. Okay, delete. Okay, key, right? So we add the key and doesn't really matter because I can pass this key since we have set no, but that would be wrong, right? Then we sort, okay, see, we set the key the max value. We sort this will push the element to the end of the map. Okay, so we need to pass the key. Okay, we will pass the key itself. Okay, so we need to update, since we are optimizing the radix sort by finding the min element up to which, okay, key, pass the and then it sorts right from that index up to right. Okay, good. Okay, since you're optimizing the radix sort by finding the min element, uh, finding the element with key just small enough. Okay, what? Right. And if we wish to add that and -1, and if we check that key that low is neither, then we simply okay, let's take a little break. Okay, so I was thinking and I thought that radix map sort right map sort shouldn't take the key, it should take the rather the position index to start sorting. And we can compute right in the add before we call radix map find, and we pass the min position key right, key to add or delete right. Fan we just go key right. You are trying to delete an element and pass the same key right. So we got this, just want to add, then I go here, then we first key, and we don't pass in the key, we pass in this main position, or I should rather say index to, what have I named it, value to find and index to start sorting. Okay, so I'll go index let's go with a const. Index represents the index from where the algorithm should start sorting right. So we go with index, then index, and that's good. key, right? Okay. Then, okay. Suppose we'll go index and we pass in the index. So we'll go small enough. Then, okay. Okay. Date. Since we are optimizing the radix sort, when we delete an element, we will find its current index, then update the corresponding key and pass the index to radix sort, right? So I want this element data dot key, right? Then we update the key and this should work now. Okay, so we'll check here, clean, make, okay, key to add, key less than. Okay, so I have to update some places. Okay, so what do I call it? Right. Say, what do we call this? Given key. Say we will call it temp key. Temp key should be less than key to add, and temp key then right. So right, 1 2 3. Okay, now let's test deleting it. Right. Okay, let's deleting elements. How do we delete? We pass in the element itself. Okay, we are passing in the element itself. So I think when you're deleting it, we find the element. Okay. So okay, if we have the key, right, to find if I am actually passing the key, so based on the key, when pause at, I will say, let's call it index and index. Okay, compute the position, compute the index of the element, right? Okay, so this is redundant over here to pass the element. Okay, let's deleting element once rme element el equals radix map underscore find map and the key is, let's say, 3. Written there, see some key, and if the element exists, we simply return its index. Okay. So radix map, then we go radix map delete, right? Map delete, we pass the map and the element itself. Pass the mu assert el should not be equal to null, error, cannot find element. We pass in the key, right? Radix map find. I find men sort to find, and we check the to find key, right? Right. Okay. Delete map comma el, and then we display the map. Okay, so we deleted 3 and it is just, I want to delete 2. One and 0. Well, that is wrong, that is wrong. It should be 1 and 3. It should be 1 and 3. So where am I getting the 0 from? Right, adding is good. Now I have to fix deleting. Find right, so map dot key in the index, then we sort up to the okay, how is its key right, 2. Okay, it finds 2 element, right? Then okay, let me try passing 1. What happens when I pass 1? 2 and 3. See, okay, it works on that, but if the element is in the middle, it gives me a 0, which is wrong, right? Because when we sort, uh, then it is doing the sorting wrong. Okay, let me get the, let's print f index u index. Gotta add the new line. Okay, so the index is 1, which is right, and so when we sort it, index is 1, and what is the end? Percentage size g, and so let's go with this. And and is 3. So we sort from 1 to index 2, right? Okay, so we sort from index 1 up to 3. Index sort this function, and okay, so goes up to its end equals to, so plus max is end less than end, right? Okay, so there is something wrong with that. Okay, we'll fix it later. So for now,